This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to today's discussion. We're diving into the fascinating world of interactive physics simulations, specifically focusing on a tool called the Floating Block Stability Simulator. It's a JavaScript-based HTML5 applet designed to help students understand buoyancy and stability.
Indeed. This simulator offers a unique way to visualize complex concepts in fluid dynamics, making abstract ideas tangible and engaging for learners.
It's not just about visualization, is it? The simulator allows for interactive manipulation of variables, right?
Precisely. Users can adjust the block's dimensions, its position in the liquid, and observe the resulting changes in real time. This hands-on approach fosters a deeper understanding than passive observation.
And what about the physics principles at play? What core concepts does this simulator help illustrate?
The primary focus is on buoyancy and stability. The simulator demonstrates how the buoyant force, the upward force exerted by a fluid, interacts with the weight of the immersed block. The shape of the block, specifically its width-to-height ratio, significantly impacts its stability.
So a wider, shorter block is more stable than a taller, narrower one?
Generally, yes. A lower center of gravity relative to the center of buoyancy contributes to greater stability. The simulator allows students to experiment with different ratios and see the consequences firsthand.
The interactive nature is key, isn't it? It's not just about seeing the results, it's about actively exploring the cause and effect relationship.
Absolutely. The ability to manipulate the block's position and dimensions allows students to test their hypotheses and develop an intuitive grasp of the underlying physics. The inclusion of drag force, proportional to velocity, adds another layer of realism to the simulation.
That's a nice touch. Adding drag force makes the simulation more realistic and helps students understand how real-world factors influence the motion of objects and fluids. This simulator is an open educational resource, meaning it's freely accessible. Who is the intended audience?
Primarily, it's designed for students learning about buoyancy and fluid dynamics, but it's also a valuable tool for teachers, providing a dynamic way to demonstrate these concepts in the classroom. Anyone interested in physics can benefit from its interactive nature.
Let's talk about the simulator's features. What are some of the key functionalities that make it so effective?
The adjustable block is central. Users can modify its width-to-height ratio and vertical position using sliders and drag-and-drop controls. Standard play/pause/reset controls allow for controlled experimentation. It even has a full-screen mode for better visibility and the ability to embed the simulation in other web pages.
How can educators best utilize this simulator in their teaching?
It's perfect for classroom demonstrations, illustrating the effects of block dimensions on stability. Students can use it for virtual experiments, answering questions about buoyancy and stability. It's also ideal for self-paced learning, allowing individuals to explore these concepts at their own speed. The study guide included with the simulator provides a framework for learning goals and assessment.
Are there any limitations to the simulator? Does it perfectly represent real-world scenarios?
Like any simulation, it simplifies certain aspects of reality. For instance, it doesn't account for factors like the viscosity of the fluid or the complex shapes of real-world objects. However, it provides a valuable starting point for understanding fundamental principles. Further development could include more sophisticated models and more detailed learning goals.
Who developed this simulator, and are there any related resources available?
It was designed by Fu-Kun Huang of National Taiwan Normal University, with contributions from Fumont Tang and Lu Pengwei. The platform hosting the simulator offers a wealth of other physics simulations covering various topics. There's also a linked video explaining Archimedes' principle.
The accompanying study guide includes a quiz and essay questions. What's the purpose of these assessments?
The quiz tests basic understanding of key concepts like buoyancy, stability, and center of gravity. The essay questions encourage deeper critical thinking, prompting students to analyze the relationships between these concepts and the limitations of the simulation.
And the glossary and FAQ section?
The glossary provides clear definitions of key terms, ensuring students understand the terminology used throughout the simulation and study guide. The FAQ addresses common questions about the simulator's functionality and purpose, providing quick answers to user queries.
So in summary, the Floating Block Stability Simulator is a powerful tool for teaching and learning about buoyancy and stability. Its interactive nature and open accessibility make it a valuable resource for educators and students alike.
Precisely. It effectively bridges the gap between abstract concepts and tangible experiences, fostering a deeper understanding of fundamental physics principles.
That was a great discussion. Thank you for your insights.